Students and friends, this is your host and teacher Sayyid Ayazuddin Haider, and you are watching Learn and Teach by Sir Ayaz. So I was doing the paper 0620 and I'm done till variant 41. This time I have selected the variant 42. It's May-June 2023. I'm not going to read the instructions as you all are aware of the instructions. So let's start the paper. Number one, a list of oxides A to H is shown. A. Calcium oxide. B. Aluminum oxide. C. Silicon 4 oxide. D. Sulfur dioxide. E. Carbon dioxide. F. Iron 3 oxide. G. Silver oxide. H. Carbon monoxide. Answer the following questions about the oxides A to H. Each letter may be used once, more than once, or not at all. State which of the oxides A to H A is responsible for acid rain. So if you look at the oxides, you will find some non-metal oxides in the list. Silicon oxide, silicon 4 oxide is a non-metal oxide, sulfur dioxide, carbon dioxide, and carbon monoxide. So we have three acidic oxides here. All these three are acidic oxides. But the oxide which is responsible for the acid rain is sulfur dioxide, not other two. Carbon dioxide also form acidic solution, but it is not the main culprit behind the acid rain. So I will write D here. B has a giant covalent structure. So we have covalent structures, silicon 4 oxide, sulfur dioxide, carbon dioxide, and carbon monoxide. But silicon 4 oxide is the only one which has giant covalent structure. So C will be the answer here. Number C is a reducing agent in the blast furnace. In the blast furnace, during the reduction of iron 3 oxide, this is the reaction equation, Fe2O3, carbon monoxide is the main reducing agent. We will get iron and carbon dioxide. I'm not going to balance the equation this time. So carbon monoxide will be the answer for this part. H. D is a main constituent of bauxite. What is bauxite? Bauxite is the ore of aluminium. And the main constituent of this bauxite is aluminium oxide. So B will be the answer for this part. E is the main impurity in iron ore. The main impurity in iron ore is silicon 4 oxide. Here is silicon 4 oxide, so I will write C here. Part F can be reduced by heating with copper. If you heat it with copper, it can be reduced. So this metal oxide must contain the metal which must be lower in the reactivity series than copper, and it must be not other than this silver oxide in these choices. So I will write G here. Moving to next question. Number 2, fluorine, chlorine, and bromine are in group 7 of the periodic table. A. State the name given to group 7 elements. Here we have group 7. These are the group 7 elements. We have fluorine, chlorine, bromine, iodine, astatine, and tennessine. So they are known as halogens. B. Explain why group 7 elements have similar chemical properties. If you look at these elements, look at the group number. Group number tells us the number of valence electrons. They all are having same number of valence electrons or outer shell electrons. So you write same number of valence or outer shell electrons. C. Complete table 2.1 to show the color and state at RTP of some group 7 elements. We have fluorine, chlorine, bromine. Fluorine is pale yellow gas at room temperature and pressure, so I will write gas here. What about chlorine? Chlorine is yellow-green gas, yellow-green gas at room temperature and pressure. Bromine is reddish-brown or red-brown liquid. Part D. Bromine has two naturally occurring isotopes, Br79, Br81. Number one, state the term given to the numbers 79 and 81 in these isotopes of bromine. They are either nucleon number or mass number of these isotopes. Nucleon or mass number. If you look at the periodic table, here you have bromine. You can see 80 and 35. Small number is the proton number. Big number is the nucleon number. Number 2. Complete table 2.2 to show the number of protons, neutrons, and electrons in the atom and ion of bromine shown. So we'll look at the periodic table in order to see the proton number of bromine. Here it is bromine. Proton number is 35. So number of protons should be 35 for both of these straight away. For bromine 79, I need to subtract 35 from 79 in order to get the number of neutrons. 79 minus 35, 44. What about the electrons? Electron, it's a neutral atom, so electron number should be same, 35. What about Br minus 81? So 81 minus 35. 81 minus 35. 46. 46 is the number of neutrons. What about number of electrons? If you see there's a minus charge, so it means it has gained one electron. Gained one electron. So I will add 35 plus 1. 36 will be the number of electrons for this ion. Number 3, table 2.3 shows the relative abundances of the two naturally occurring isotopes of bromine. We have bromine 79, 55%, bromine 81, 45%. Calculate the relative atomic mass of the bromine to 1 decimal places. So what we will do, we will multiply the mass or nucleon number of each of these isotopes by the relative abundance. So we have 79 multiplied by 55 plus 81 multiplied by 45 divided by 100. 79 multiplied by 55 will get 4,345 plus 81 multiplied by 45, 3,645 divided by 100. 4,345 plus 3,645 divided by 100. What we will get? We will get 79.9. This will be the final answer for this question. E. Chlorine displaces bromine from aqueous potassium bromide but does not displace fluorine from aqueous sodium chloride. Number 1, write the symbol equation for the reaction between chlorine and aqueous potassium bromide. Chlorine, they are halogens, they all exist in the diatomic state, so I will write Cl2 for chlorine. What about potassium bromide? Potassium bromide, KBr. Bromine, here we have bromine, it's in group 7, so valency is -1. Potassium, here we have potassium in group 1, valency is +1. So if you ignore their charges, you have 1, 1, and do the cross, what you will get? You will get KBr. So KBr will be the formula for potassium bromide. The product will be KCl and Br2. Bromine is also halogen, so it will also exist in the diatomic state. Let's balance the equation. Place 2 here and 2 here. This will be the final balanced equation between chlorine and potassium, aqueous potassium bromide. Number 2, state why chlorine does not displace fluorine from aqueous sodium chloride. If you look at the position of chlorine, here we have chlorine and fluorine is on the top, and you know the reactivity trend, it decreases down the group, which means that chlorine will be less reactive than fluorine. Chlorine less reactive than fluorine. F. Aqueous silver nitrate is a colorless solution containing Ag plus aqueous ions. Number 1, describe what is seen when aqueous silver nitrate is added to aqueous sodium chloride. So this aqueous silver nitrate is also used to identify the halide ions, that is Cl negative, Br negative, and I negative. So Cl negative ion will be identified to the change in color. The change in color will be white precipitate or white PPT. White precipitate. Number 2, write the ionic equation for the reaction between aqueous silver nitrate and aqueous sodium chloride. Include state symbols. So here we have a reaction between silver nitrate and aqueous sodium chloride. The formula for aqueous silver nitrate is AgNO3. It's an aqueous state, plus sodium chloride. Sodium in group 1, chlorine in group 7. So the valency will be 1 for both of these. The final formula will be NaCl, aqueous. This is an example of displacement reaction as well as precipitation reaction. So what will happen? The partners will be exchanged. Ag will combine with Cl and Na will combine with NO3. So what we'll get? We'll get AgCl. AgCl will be in solid state, and NaNO3 will be in aqueous. NaNO3 aqueous. Now, in order to write the ionic equation, I need to break up the aqueous only, not solid. This will not break up. Not break up. Okay, so AgNO3 will get Ag plus aqueous plus NO3 minus aqueous plus Na plus aqueous plus Cl minus aqueous gives AgCl solid plus Na plus aqueous plus NO3 minus aqueous. So spectator ions will be cancelled out. On both sides of the equation, you will see NO3 is a spectator ion as well as Na. These will be cancelled out. So in the end, we will be left with these ions. Ag plus aqueous plus Cl minus aqueous gives AgCl solid. This will be the final ionic equation. So I will write it down here. Ag plus aqueous plus Cl minus aqueous gives AgCl solid. Question number 3. Over 200 million tons of sulfuric acid are manufactured every year. A. State the name of the process used to manufacture sulfuric acid. The name is contact process, so you write contact process here. B. Part of the manufacture of sulfuric acid involves converting sulfur dioxide to sulfur trioxide. Number 1. Describe two methods by which sulfur dioxide is obtained. Now you can burn sulfur in air, or you can involve sulfur ores like zinc blend and roast it. So I will write burning of sulfur. Burning of sulfur in air, or you can have, you roast sulfur ore, sulfide ores in air, like zinc blend. Zinc blend is ZnS. The conversion of sulfur dioxide to sulfur trioxide is a reversible reaction which can reach equilibrium. This is a reaction to SO2 gas plus O2 gas gives 2SO3 gas. Number 2, state two features of an equilibrium. So you have to write two features of the equilibrium. So the concentration of reactants and products remain constant or are no longer changing. Concentrations of reactants and products are no longer changing. The rate of, number 2, the rate of forward reaction is equal to rate of backward reaction. Number 3, state the typical conditions and name the catalyst used in the conversion of sulfur dioxide to sulfur trioxide. These are the conditions. We have 450 degrees centigrade as a temperature, and we have 200 kilopascal as a pressure, and catalyst is vanadium 5 oxide. Vanadium 5 oxide. Moving to next part of this question. Number 4, complete table 3.1 to show the effect, if any, when the following changes are applied to the conversion of sulfur dioxide to sulfur trioxide. Here's the equation. The forward reaction is exothermic. Only use the words increases, decreases, or no change. So what will be the effect on the rate of the forward reaction if temperature decreases? What about the concentration of SO3 at equilibrium? Forward reaction is exothermic, you see, so it should favor low temperature. So it will definitely increases if you decrease the temperature. Now what happened if you increase the pressure on the rate of reaction? It increases, and for the effect on the concentration of SO3 at equilibrium, if you see the number of moles on the reactant side is 3, product side is 2. So it should favor high pressure. So you'll have high concentration of SO3 at equilibrium. So you write increase. What about catalyst? If you are not using any catalyst, so the rate will be decreased. But what about the concentration? Catalyst has no effect on the equilibrium. So you write no change. Next part, number 5, explain in terms of collision theory why reducing the temperature decreases the rate of the forward reaction. So kinetic energy of the particle decreases, frequency of collisions between particle decreases, and you are having fewer particles having energy greater than or equal to activation energy. This is of 3 marks. So you have to write 3 statements. Kinetic energy of the particles decreases. Frequency of collision between particles decreases. You have fewer particles have energy greater than or equal to activation energy. Number C, sulfuric acid contains SO4 2 minus ions. The oxidation number of O atoms in SO3 2 minus ions is -2. Determine the oxidation number of S atoms in SO3 2 minus ions. Show your working. So we have one atom of S. So I will write X here for S plus. There are 4 atoms of oxygen. What is the oxidation number of oxygen? It's -2. So I will write -2. And what is the charge on the ion? The charge on the ion is 2 minus. So I will write -2 here. So X -8 is equal to -2, or X is equal to -2 plus 8. You will get +6. So +6 will be the final answer. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.